So it's often really difficult to graph polynomials by hand because they make so many different turns and they go in different directions, and it takes a lot to make a good graph. And doing it by hand is just a very time-consuming process. So for regular algebra 2, I will be focusing primarily on graphing polynomials by using the calculator. So when you make a graph on the calculator, you can read the notes I wrote right here. There are three real things we're looking for. We're looking to find the roots of the equation, which will be useful later on, the x-intercepts. The maximums and the minimums are both the bumps, but the maximums are like the hills, the high points, and the minimums are like the low point on the graph. And I have here just a couple quick steps written down just to remind you guys later how to do this. So go ahead, pause the video and write these down because I'm going to go ahead and pull this away and then we'll just try it through an example. So make sure you have those down, and then I'm going to go ahead and switch over to just one example problem right here. Say we were asked to graph this equation right here. We have y equals negative 2x to the third plus 5x minus 9. If you were to graph it by hand, you'd probably just make a table and you'd eventually get it to work out, but it's easier just to graph on the calculator. So what we're going to do is go to the y equals menu, that being this top right button right here, and we'll type the equation into y1. The variable key for x, let me move this up a little so you can see it, is this second guy right here. It starts with the x next to the green button. So it's going to be, let's see, we got negative 2x to the third, and then it's plus 5x, and it's minus 9. So you just type your equation in. Make sure the plot 1 up here is not dark. Sometimes it is. If it is, you just need to deselect it and make it normal, like that. Once your equation is typed in, you're going to hit graph. And when we graph this right here, you always want to start out by hitting zoom right here in the middle. And choice 6 is zoom standard. In case you were looking at something weird or like the window was all messed up, this gives you the default screen, which incidentally is what I already had. But it's always good to do that first. Then we're going to go to the window button. Window is the second key right here. If you hit window, it allows you to say exactly what x's we see and what y's we see. So right now we're going from negative 10 to positive 10 on the x's, negative 10 to positive 10 on the y's. I don't really mess with any of the other options, so leave those alone. What we really want is to see a little more down here because we don't get to see, it gets cut off, so we don't see the bump right here. So we need to make the y min a little longer so we can actually see more. So what I'm going to do is under the window, I want to go down and change the y minimum to maybe negative, let's see if negative 15 is enough. So I can see like a little more going down. If I change that, that looks a lot better. Now I can actually see where the end behavior is going up this side, and I can see the relative minimum right there and the relative maximum right here. So I need to get an idea of where those points actually are. So move this over just a little bit. Remember, the things I need you to find before you make your graph, we need to find the roots, the minimums, and the maximums. So for the roots, and for all these points really, roots are the x-intercepts. What we're going to do is use the trace key, which is this fourth guy right here. If you click trace, it gives you a little cursor on your graph that you can move around, and it gives you points right here where it's at. So right now it's at 0, negative 9. When you do the trace key, it's an approximation. Like, it doesn't give you the exact points. So if you can see right here, my cursor is not quite on there. It skips around a little bit. Just get as close to the x-intercept as you can, and then kind of estimate that point based on what we have right here. The y is supposed to be at 0, so it's about negative 2.1-ish for the roots. Maybe negative 2. I don't know, however you want to round it right here. This is an approximation, so I'll go with just negative 2.1. This is the about where the root is. Again, it's not exact. And of course, if it's a root, the y would be 0. So we're going to estimate using trace that that's where that point is. Then I'm going to go down and get the relative minimum, the little valley right here at that bump. That bump looks like it's about, if you use trace key till the cursor's down there, negative 0.85. So this is the relative minimum. It's going to be negative 0.85 about, comma, it's negative 12.02. Again, we're approximating here, but that's about where that is. And we're also going to find the relative maximum. So any bumps we have, we got to make sure we find. Here there's only one of each. If there were more bumps, you would just use trace on each one. So we're going to keep moving that cursor and figure out about where we have that point. That one looks like it's about 0.85 for the x, and it's negative 5.97. It's basically negative 6 right there. You can round to that. It's up to you how you round right here. It's not always going to be a whole number. just do the best you can. We get these points right here, and that was totally off screen, sorry. So once we have our points, that's actually all we need to make our graph. I'm going to go to my root right here and plot that point. Negative 2.1. It's obviously like a little bit past. It'd be like a dot right there. Always got to make sure the x-intercepts are nice and on the graph because we'll use them later on in a different video. We have negative 0.85. That's a little less than negative 1, comma negative, basically negative 12. That's actually going to go a bit off my graph down here. I could always scale these by 2s if I wanted to. Or what you can do is just go 2 additional tick marks down. Negative 0.85 comma negative 12.0 is going to be like right there, tiny bit below that tick mark. So I have that point right there. Then the maximum is at 0.85 comma negative 6. So negative 1, 2, 3, 4, 5, 6. Maybe it'd be like right there. The bumps tell you when you're supposed to change directions while graphing. And you kind of use the picture right here once you have those dots to help you out. It starts out really high, and behavior is going off to infinity in this direction. And it's going to keep going down until you hit this point. That's where the relative minimum is. So it's going to be like really steep going this way. And it kind of rounds out when you hit that point. So we kind of round it. It's going to keep going back up until it hits this point. And then if you look, after it hits that point, it just goes downwards. So it's going to turn again, and it's going to go downwards like that. So we are really kind of depending on the calculator here to get the essentials of our graph, but we need those dots so we know exactly where to turn around. If you guys draw a picture where you're just like that, you just draw a real quick thing, I'm not going to give you credit for that. You need to give estimates of those points by using the trace key.